That could be more clicks to get going. It'll be good.
All right. So today we're going to be talking about debugging using Strace and Sysdig. I'm sure most of you know me, but Joshua Eichorn, CTO of Pagely. So, there's a lot of ways you can debug things, but what makes both of these tools interesting is that they're system-level debugging tools. You can use them with PHP, or you can actually use them for anything else you're working on debugging. And it also means that there's no need to, work on any version of PHP, on any install anywhere. You don't have to compile a special module. You don't have to say, well, this is a production server. I can't install Xdebug and have all my code run 100% slower. So you can just look in on anything. The difference is, like compared to say Xdebug, is you're not going to see every PHP call that's happening, every PHP function. Instead, you're just going to see the system calls. And so the main things that gives you is it gives you access to all of the I/O that's happening. So if you're talking on the network, you're going to see all that traffic. If you're reading from a disk, you're going to see all that traffic. If you're allocating a ton of memory, you're going to see the evidence of that. So that's less useful unless things are like crashing and you're not sure why. So, second question, of course, why would you use this compared to some other tools? So first of all, like I/O is the major cause of most of your performance problems. Talking to the network, talking to the disk, generally is orders of magnitude slower than the other things you might do. So knowing about them is super useful. And unlike something like say New Relic, which always has that 15, 20, maybe even 25% overhead, depending on exactly what your framework is doing, there's no overhead when you're not doing any tracing using those tools. There's only overhead when you're using them, and that overhead is low compared to most things. And then they're, in general, on a Linux system, they're very easy to install. So especially Strace. So on most Linux distros, it's already going to be there. You're not even going to have to do anything. It's going to be installed in the default set. But the worst case, it's yum install Strace or apt-get install Strace, and you're up and running. So there's a lot of filtering that you can do, so you don't have to see all the system calls. And it's pretty easy to see, but the output is raw. Like if you're talking a protocol that's binary, you're going to see that raw binary data escaped as hex. And so, it's not the prettiest, but for most things, that's fine. Most protocols are ASCII, or at least important parts are. Things like DNS, HTTP, MySQL's protocol, etc. So the other tool we're talking about is Sysdig. So this needs a kernel module. And so actually one of the other differences between Sysdig and Strace is Strace can be ran not as root. You just need the capability to run it, which a standard user on any Linux system is going to have unless it's been locked down. You really only need to pay attention to that if you're using Docker or something like that, where you have to specifically specify the capabilities needed. But with Sysdig, you have to be root because it uses a kernel module to get the data. So it's a little limited on where you can use it, but most people aren't in a shared hosting environment with just shell access. So on any new distro, it's really easy. It's either already there, you can just install with apt-get, etc., or they just have a curl pipe to bash script to install it for you. It'll add the precompiled repo for you. And what's neat is that it has a concept of chunks of code for doing protocol analysis. So it actually understands HTTP, and so you can get the nice clean decoding of that protocol rather than having some ASCII or other characters mixed in there, and it also can do summarizations using that same code. So you could get an access log from a system where logging's not set up, but still get that same equivalent output, which is really nice. And it also has a bunch of added features that are less useful for debugging, but are more useful for just, say, like a container-aware top replacement. You can use Sysdig for that, because that's the other thing, is it's fully aware of Linux containers. So you can filter down to just seeing a trafficking container. You can use it as a top looking into a container, things like that. The thing I like about it the most is it's really easy if you just want to look at all the traffic that's moving on a port. So besides all the system level stuff, it's kind of everything you can do with TCP dump, you can do with Sysdig, only it's easier. I don't know if I've tried to use TCP dump before, but the interface for it is pretty painful. Right, so that's the same thing. So you're looking at the traffic that's going over the wire. But generally, when you're debugging PHP, it doesn't matter. You know, if you're doing mod PHP and doing SSL termination all there, then you really don't get a view. But most people are using, at least at scale, you got a load balancer, you can listen to that, or you're using FPM and you just listen to the FPM traffic between the two. And that's actually a trick that you can do, you know, if you want to be a product situation to be debugging where you just do a little hop inside from port to port on the same machine and you can listen in on that. All right, so let's jump in and actually do a little debugging. So earlier this week, one of our customers at Pagely was using the Discuss plugin. They needed to upload 500,000 comments to Discuss. And the plugin, I don't know, it has like an export script, and I don't think anybody's touched it in a year. And it doesn't really work quite right. And so he goes to run it, and the first thing he does is gets no output. And that's like a really common scenario with those one-off scripts that you're trying to debug is they're not working and they don't tell you why. And it's PHP, so yeah, you could go through and start adding a bunch of ifs into it, but like, you know, this is some WordPress plugin that might be 20,000 lines of code. It's not that great to like read through that all. But it's a lot easier if you can say, all right, well, let's look at what's happening that I'm not seeing. So let me open up this case. This isn't that exact case. It's just there's a, in the azPHP Git repo, there's this repo with a bunch of examples that run in Docker for, I resized it in the other window. I missed it on this one. All right. So let's just start up. Wow, I did weird things. All right. All right, so here we're on a random Linux host, and we have this script called testcoi. And, you know, that's the output it gives you. And it just hangs there, like, what is going on? So if we want to see what it's doing, we can just run it with strace. So the flag you pretty much always use with strace is -s, which says, how much of the output do I want to capture? So we don't have a very big screen here, so let's only grab 50 characters. So when you run strace before a command, it automatically connects to it and gives you all the system calls that it's doing. So if we look through here, there's a lot of noise. What I was saying is it doesn't decode the whole protocol. So you can see that we're like, the MySQL protocol has some binary bits around the edge, but you can still follow what's going on here. And most importantly, like, you see this poll going on. Poll is a system call that means wait for something to happen. So if you look right above that, you'll see that we ran the select sleep MySQL query. And so this is why this is slow, is it's running a SQL query that takes 20 seconds. So we can actually do a little better than this. No, it terminates just like normal. In fact, if you look at the end of this where it says m on map, this is the way PHP scripts always exit, is they on map all of the memory mapped memory that they used. And so there's always a bit of, PHP scripts always look the exact same way when they end. So the one thing that you can do, I said there's a lot of filters for that. And the man page has the whole list, but you really only use 2 of them. Let's see, I have a text file with this all open, but
can't really. So we can say, instead of showing us every system calls, just show us the ones related to network activity. So when we do this, instead of that huge list, we just saw those pertinent ones, which says, you know, up here you can see where we're connecting to, you know, DNS requests in partial binary format are a little hard to read, but it's still obvious what's going on there. You see we'll connect to an IP address, and then we'll make that, and the last thing before we paused was this select star from user. So this is the sort of trick that all the time we end up using. And it might be good too, like, you know, let's say you have a script that just does a lot of stuff. Like maybe it runs, it's doing a data import, and you forgot to write any status output on it. And so you're wondering, it's been running 4 hours, still doing anything? So you can just, the other way that you can use strace is that if a script is running, it's a little painful for side-by-side here with this low resolution. All right, so if the script is running, all right, sorry, I'm in the wrong example for showing this. This is when you're working with a Docker distro, you don't have even the normal stuff by default. But yeah, so there's another flag we can use. Let me just jump over to the next set of examples. So if you have something running, you can attach to that running process and see it. And so the most common case that where you do that might be if we were wanted to watch what was happening in a PHP FPM process. So instead of just having a script that we want to debug, say, all right, what's it doing? Why is it stalling? Or what's the status of it? We can and if you look through the repo, in each one of there's an example shell file that goes through and runs a bunch of examples. So if you want to take this from home, there's in the Git repo, there's working examples to look at. All right, so here, all right. So here we got a case where we set up PHP FPM and it doesn't work. Right, so if we say curl localhost, we get file not found, which is odd, right? That's not like a normal Nginx 404. Like, so if we do that, that would be a normal Nginx 404. But here, Nginx says the file exists, but PHP FPM says it doesn't. It's like one of those classic config errors that you make. And if you look in the logs, there's nothing. There's no way to see what file PHP FPM didn't say was found. You would just have to know because you've seen this problem before, or you could use strace to figure it out. So we actually have PS in this guy. So the first thing that we do is we say, all right, you know, before when we were running one script, we had one process to attach to and watch. But now we have 5. So how can we do that? Well, the nice thing is that strace takes the P flag, which is the process to attach to. So 11, and you could just do that as many times as you need. Oh, it's so painful. So if we run to that, we've now attached all those processes, and we can see what's going on. So let me hop over here to the other terminal. And if we curl localhost now, it's a little painful with 2 screens here, and we could see that this is the output we got. We happen to hit the PID15 worker, but it's pretty random on which PHP FPM worker could respond. All right. So if we look up on the screen, you'll see a whole bunch of system calls that happened here. And a whole bunch of them you can just pretty much ignore. And so that's why often I'll use strace filter. But if you're ever going to look at them, the ones that you care about when you're looking at files are going to be the ones that are stats. Because whenever PHP goes to load a file, the first thing it does is stat it to see if it exists. And then it stats the parent directory to see if there's something there in your PHP config that say, even though it exists, I couldn't read it. And so you end up seeing that whole chain here. And what we see here is that we got this lstat of /temp index.php. And so say, oh, that's pretty weird because I'm pretty sure when I set this thing up, I put my code in var www html public index. So obviously there was our config problem, is that when we were passing the document root over to it. So there's a couple other things to quick go over here is, well, first you saw like you do PS, then you had all those P flags in. That kind of sucks. But thankfully, you know, you can Google for this or just look in the slides, is you can just use a really simple one-liner to build all those dash Ps for you based on a grep of the process list, which is pretty much what we do all the time. So let's take a quick look back at this. So let's say we're all right. We know that there's something wrong in the configuration. So let's look at what Nginx is doing and see if there's anything useful there. So this is pretty much the exact same command as before, only instead of me doing the PS and figuring out what PIDs, there's just this little one-liner that I copied from Stack Overflow that does it. So we connected to the worker there. There happened to only be one. And now if we curl localhost, we'll see what Nginx did, which was it wrote a chunk of FPM code to PHP FPM. And this is kind of one of the areas where strace isn't that great. So if you have a really long chunk of text, it's all going to be smashed into one line. There's a couple ways you can get around that. So one, strace has the option to output to a file. So you can output to that and then open it. The other way is to, instead of using strace, you can use Sysdig, which I'll show examples later, because it does protocol decoding, and so it gives you nicer formatting output. With strace, you don't have a ton of options there. But in this case, we could output it to the file like temp trace. Run it there. Oops. It's a different example. You could, except for strace by default outputs everything to standard error because it's often used when running with another script. These guys got in the way. So if you want to, if you want to do that, all right, so there we just put our trace to the file. So we could look at it in there, open it up in Vim, do a search and replace, and then the control ends to find what we need. So if you wanted to use less, there's lots of ways to do it using shell redirection, etc. But I normally just do tell it the output file is dev standard out, and we can type to less and get it that way, which is an easy trick. So yeah, so if we're looking at this in less, you'll see that the document root is right, var www html public. The script name looks right. Oh, I might not have got enough of them. But in any case, the FPM protocol is particular in the fact that you set the document root multiple times, and it's just one of them is wrong in our Nginx config. So let's quick hop out of this to a working Nginx config to kind of walk through the second set of debugging. So instead of, whoa. All right, so let's go into test working. All right, so if we curl this local host, then you see we have a working FPM config. It's running a little slim app that says hello world. And so this is kind of the real life debugging of, this is the real common case. I curl your test curl that somebody says is slow, and yep, it's slow. Everything's slow as expected. So you go and you look in your logs, var log, var HTML, slim app, so it has an app log. There was nothing useful in the app log. You could look in the PHP FPM log, but there wouldn't be anything useful there. So say, all right, well, we'd like to find out why it's slow. All right. Oops. All right, this is the one I want. All right, so we're running it through here. And so the one thing you'll notice here is that when you run something that's a PHP framework, you get a lot of file access, because for every single PHP file, there's going to be at least 4 system calls. So this is one area where using that filter to just look at network can be super useful. But this is actually an interesting trick that you can play on yourself. There's a couple system calls that are super easy, super useful to know the names of. And one is nanosleep. And that corresponds to somebody running usleep or sleep in the PHP code. So this code was slow because I played a trick on myself and threw a sleep in there. So that's pretty easy to debug. Because you know that nanosleep corresponds back to PHP sleep, then you could grep in the code and figure out what's going on. And so that's always kind of the way you work with these tools. They're like, they're outside in debugging. So you'll know the kind of the outer world action that was slow is the cause. And then you'd have to map that back to. If it's a query, you'd have to pull the string out of there and grep for it in the source code to find it. Or you have to say, oh, well, it's worth now going through and configuring the full debugging logging for all the SQL queries in my framework, since I know where to dig into. Or if it's, you know, in the case of a nanosleep, you'd be like, all right, who's the joker who's putting random sleeps in our code to make it slow? Like they wanted to be the winner on the performance challenge, so they just made their code super slow. All right, but you know, that's not necessarily the best example. So a better example might be a page that's slow doing something real. Let me just copy this because I don't ever remember that one-liner. All right, so now we're watching PHP FPM. Let me just join you. So we have another script here, only it is slow because it's doing a lot of something. So whenever you're doing an strace, there's kind of two things that I always find super useful just from watching it scroll. You don't have to look what's on the screen. So one is if there's a pause. That means you did some sort of I/O or system call that's slow. You could be reading a couple gig file. You could be making an API call to Twitter and they're just slow because they love being slow. Whatever that thing is. The other thing that's really telling is when it's scrolling super, super fast like this. This means that you're doing a lot of I/O in a loop. So we'll just hit Control-C here, make it stop scrolling. And so you'll see that over and over what we're doing is we're sending what looks like a SQL query and we're getting back a response. And then we're doing that over and over again. But you might, so this is super common, right? Instead of writing a smart SQL query, they did a for each loop and ran a SQL query in every item. And now you know that's the sort of pattern to look for. And you have the query that was run, so you could grab against the code base to find it. But this could also, the same pattern could happen, and it would look very similar if you were getting back huge amounts of data. But instead of continuing sending, you would just see pull and receive over and over. Because what you're doing is saying, all right, is there more data from the network? All right, get it. Is there more data from the network? You can get it. So that's the great example of somebody selects star from users and you happen to have 5 million users. They try to load them all into PHP. In a case like that, you would also actually see some additional system calls. There's a fun one called PRK. And what that means is the stack got resized. And so anytime you see that in PHP, that means somebody's using huge amounts of memory. So if you see do an strace and you see a screen full of BRKs, I mean, it's probably going to be followed up later with a memory failure, unless you have like, you allow your PHP processes to run to 8 gig. But that's a good example of like where, yeah, I'm sure that's how Tim runs them. No memory limits. But that's a good example of a case where you now know the problem, but this isn't necessarily the easiest tool then to dig down on what is doing all those allocations. But at least gives you a place to start. So in this case, we knew that we were doing tons of SQL queries in a loop. If we saw a bunch of BRKs, we know we were allocating tons of memory. And both those would at least give us a place where to dig into and tell you what other tools are worth looking at. Yes? I don't end up doing that too much because most of the time in PHP code, you'll see those stats of the file being included and then something being run, and that's already your marker. But it's very easy. If you want a marker, you just write out to a file. You're going to see the contents. You see the stat on the file name and then the contents you write. So it's very easy to add markers. But yes, I don't tend to have to do it too often. But yeah, so obviously HTTP, I don't have an example here, but HTTP is just as easy to read as MySQL is. You're going to see those head requests in it. And well, this example isn't good for that, but in that earlier example, when you connect to it, you're going to see a connect and an IP address for what that network is. And especially, if you have an idea of what's going on, filtering down to just seeing the network activity is a really good way to make the traces more readable. All right, let's see. Is there anything else to cover with strace? Yeah, so here's the thing. You have two different scaling challenges in scaling PHP and scaling serving web traffic. And when you combine those two pieces into one, they have to scale at the same rate. So the way PHP works is when you go and you process a request, memory is going to get allocated. It's not going to be released back to the OS. So in each one of those Apache workers, you're going to go through, and let's say you end up with 50 of them. All 50 of them are going to balloon up over time to whatever your max memory use needed for PHP is. And it's only going to get released when that Apache worker comes back. But you may, really, so that makes scaling hard, right? Because now, even though maybe only 5 or 6 PHP processes are ever running at once, you have the memory allocation of 50 at all times. So that really gives you this big unbalance. And the other thing is, well, actually, maybe you also serve a bunch of static files from that content or need to do rate limiting against the text. And so the correct amount of workers for Apache might actually be 200. But if you did 200, you'd have the memory allocation of 200 PHP workers. And then you're really, it's just the amount of memory needed could be insane. And so by using FPM, then you can say, oh, well, actually, I get the best throughput for my application at only 8 PHP workers, because then we're not spending so much time context switching. And you can scale that for its needs and then scale Apache for whatever its needs are. And then also, of course, you can easily, once you pull PHP out of Apache, you can stop using Apache. And then you have Nginx or a much more scalable web server that's, at least in my opinion, a lot easier to do interesting things, caching, things like that, which can be done in Apache. It's just a little painful in Apache. And then, of course, the other thing is, if you were tracing in Apache, it would work just the same. It's just you would see a bunch more junk around what Apache's doing at the same time. Yep, because the Apache process and the PHP process are the same. So like, you know, that grep you wouldn't be able to just grep against the process tree list. You would have to use a PS using the parent PID ID to get all the children. But you can Google for that too, and it's the first result that comes up is a whole list on how to build that by hand. Or in my case, I always end up just searching through our Slack history because Oscar gave it to me before. And all right, so let's see if there's any other cool tricks we want to show on Strace before we move on to Sysdig. Oh yeah. So the other thing, and it's that that Strace is really useful for, is when you have broken the logging on a site. So a permission problem, whatever the configuration problem is, and you know the site's got a 500, you know you have great error handling, it should be spitting out an error, the error is nowhere to be found. So you just trace it, you'll see the error that says I tried to open this file and doesn't, and then you know exactly what the configuration problem was to get your logs back. And you can also have cases where like the errors are getting sent to standard error, but your Apache or Nginx config is just throwing that away. But now you want it, you can attach to that and you'll see that that's being written to standard error even though it doesn't end up in disk anywhere. And that's a great way to get into those cases. And something I end up using a bunch because I'll be configuring something, this or that, on a Docker instance for testing and have no idea what I'm doing because this is like the first time I've ever used this package. Like, if I could just get the logs to work, I could figure it out. And this is how you just get the logs to work. You see the file they're trying to write to, you fix the permission problem, and then you can move on. No, so you just strace the FPM or whatever the process they have misconfigured is, and you look for the error and lstat with an error after it. And then I'll say that'll be the log file that was trying to be written to. And then you can create that path. Yeah. And then if you have some errors being written to standard error, but something's eating standard error, you'll just see them. It'll just be a write, and you'll see all the text that would be written. We actually, in our stack at Pagely, for some HTTP error codes, we show like a fancy error page directing you to support. But in some cases, a WordPress plugin will actually be outputting an error message that you need to know in that case. But with Nginx, there's no easy way to be like, sometimes for this HTTP code, capture the error, and sometimes don't. You either get to or you don't. And so the trick when you really have to know what that error message is you trace that FPM process, and you see all the HTML it's outputting. And it doesn't go anywhere else, but it's getting written and then thrown away, and you can see what's happening. It's such an intractable problem in Nginx. It's so painful. All right. So Strace is great. It's super easy to install. It's generally there. You don't even have to be root to use it. So if you just have shell access at somewhere and you're trying to figure out what that script's doing, you can still use it. But sometimes, like, you want to output this nicer to read. You don't know what process is talking on port 9000, which is, like a really standard FPM port. You don't want to figure it out. And that's where Sysdig comes into play. Now, hopefully we don't have any network problems here. Yes, either a network socket or a Unix domain socket. Either way, you can listen into the traffic. So to a system call, to the Linux kernel, everything is just a file, really. And so you're just jumping in on that. All right. So the one thing is, if this is like one of the cases where like I'd hop over to a Linux system to get Sysdig installed. So like Docker on Windows runs a Linux distro inside of Hyper-V and then hides your access to it. But if you're doing anything containerized and want to do Sysdig, Sysdig has to be set up on the root system. It can't just be set up in a container, where strace could be set up just in a container. So this is like one of the cases where like to run Sysdig, you really have to have full ownership of the system. It can't be a container or anything like that. You have to be able to get all the way to the root of the parent. So there are some cases where you can't use it, but it does offer some interesting additional features if you can get it up. So let's do the same thing. Let's start another test environment. And then let's hop into that environment. Oh, I need to do this twice, don't I? Actually, we don't need to hop into it. All right, so we have our same test app here. It says hello world. And so if we want to watch, actually, I guess I'm going to need two windows anyways. Yes. Sure. All right. So, all right, curl. So Sysdig is very similar to strace, and the fact they both look at system calls. The way they get the data is a little different. And this with strace, we were always looking at one process at a time. But with Sysdig, we have a kernel interface, so we can look at the whole system at a time. In fact, if you were just to run Sysdig, you would get this huge spew of every event that's happening from your kernel. So, you know, we see that SSH is doing signal handling and a whole bunch of junk that we can just ignore. Unlike trace, where we have a one process view with Sysdig, we start from a system view and then we drill down into which part of the system we want to look at. So like in this case here, if we want to look at the network request that was happening, we could say, just look at my example here. Oh wait, I got ahead of myself. So whenever you're working with Sysdig, so there was that initial output that was like every event, but you don't really want to work with that. That's actually mostly there for you could store it to a file and process it later. But Sysdig has the concept of a chisel, which is just a script that's been written to do something useful with that output. So if you use the CL flag, it shows you all of them. So if you look here, you go, oh, cool, there's one called HTTP log. So we could do sysdig-c HTTP log. That's probably enough. All right, so now it's looking in the system for anything that looks like an HTTP protocol request. And so if we make one, I guess I'm going to need to split these differently. Slow resolution is painful. All right. All right, so when we make a request, it shows us the HTTP request that happened. It all shows up twice here because we're using Docker and there's a userland proxy. So first the request goes to the proxy, then it goes to the container and back. So that's why things are showing up twice. So we could actually get rid of that if we wanted by filtering down to the container. Equals. I think that's the right container name. And so now when we do the request, we just saw the output from the container. And so that's kind of the difference with Sysdig, right? So we're not looking at a single process. So it's a little harder to use if we want to say, I ran a CLI script, what's it doing? But if we want to say, all right, I have a service that I care about, what's it doing? And especially as you saw here, I was working in a container. But that's not the only way we could filter it down. So we could filter by the port that things are running on or things like that. The other thing we saw here was that this chisel just gave us this formatted output. But let's say if we wanted to see the raw details instead, we could do that too. So, oh man. Maybe if I can scroll in a reasonable way here. Echo FDS. All right. So earlier I said to the Linux kernel, everything is a file. And Sysdig has a chisel that takes that concept to heart. And it's called Echo FDS. So that's just echoes out all the traffic going through a file descriptor. I did. So like if we just ran this, it would show us all of the descriptor traffic that's happening, which because we have an SSH session is a lot. So we'd want to start filtering it. So we could say file descriptor dot port equals, we could do 80, and then we, likely, I do not know all of the ins and outs of the query language that's supported there. Yeah. And see, so here we have the request that's going on, and is it? All right. So we can also do, there's a flag to Sysdig called -a. So without that flag, we get the request in a raw format where it uses dots for the binary chunks. And with it, it does full ASCII decoding for you. So that when we're doing an HTTP request, we get a nicely decoded output that we can use. So we see our core request, we see the request, the response, and it tells us the directions of where things are going. And when there's multiple services involved, like there's multiple hops, you can see all of those if you're a little filtered down to allow them, or you can filter down to just a single one, whether that's filtering by port number. You can actually filter by process ID, but I'm not less useful for Sysdig. I spend more time doing ports. Like a good example where I used this with the HTTP decoding like this. I was trying to debug a plugin that talked to Elasticsearch, and I needed to see the queries it was sending. And I could have patched it up to add that functionality for it to log it, but that was figuring out where the actual request in the chain was fully complete and I could log. It was pretty hard. It wasn't using Guzzle or something nice. It was using its own homegrown HTTP code. So this way I could just see all the network traffic really simply. And you can even do additional filters. Though I'd have to look at the syntax. I don't have it written down. But you can do filters against the contents of this HTTP request. So you can just see all the post requests and not the other ones. Or you would say, I want to watch people with this session ID. You can do a filter against that after you've seen them the first time. So there's a lot of options to filter down what you're seeing. Right. Because the filters are against the buffer. And you're seeing the decoded version because you want the decoded version. Yeah. But yeah, so this is super easy. Another thing is, and this is the reason why you should oh, what's it called? It's by users. Is that if you're ever on a system and you think it's been compromised, or you got a Docker container that somebody is compromised in, you can run spy user, and then it'll show you everything that they're typing into the console. You can also do this just if you want to mess with people on a shared machine. But so there's like this secondary set of Sysdig features where people use this for when they're setting up honeypots, and this is how they watch what's happening inside it. And then they're able to do that monitoring without any code running inside them, showing what's going on inside that container. No, well, so if you were just if you didn't have any containers involved or something, if you want to use it for a honeypot, you would need to run low privileged containers where that was in, and then use Sysdig to watch just that container. And so you could use this with the flag to limit it to container.name, to just limit it to that container. Right, so this chisel. So, you know, you can use Sysdig to add in logging like that on anything. And there's a whole chunk in the manual on how you can use Sysdig to add in logging to systems that don't have it. So like if you're running a web server and it's so high traffic, you don't normally want HTTP logs on, but you need them for certain periods of time for debugging, or maybe for certain sets of IPs, you use a Sysdig script to watch the HTTP traffic going over the wire and to log just for that. And it's reasonably low overhead that, you know, it wouldn't cause issues. And then he also has support for integrating with statsd. So you could use that to do that analysis and then send the data off to your graphing service. The company behind this is actually their product, is they sell like a Datadog equivalent, only instead of having to tell it about all your logs and everything, you just install this single agent. It watches the traffic on it and just automatically says, are you using MySQL, logging MySQL, you're using all those, and just looks at the protocol traffic goes on and automatically starts spitting out stats on it. Which is pretty slick if you're like, I need to get everything set up and I don't have like a month to do that.
Or it's pretty slick. Maybe I'm wrong.
Yeah, so we're using in a system that's containerized. It's like, well, I don't want to put all my logging stuff into each one of my Docker containers, which are only supposed to do one thing. But which container lives where changes based on a bunch of rules, and when things fail, and instead of having to figure out how to make all that work, we just installed this, and we got graphs and charts with like zero setup. And it'll even like know to be like, the company behind Sysdig is I mean,
Well, just Sysdig.
yeah, Dryos is the company name. But yeah, I mean, some of the UI stuff on their product is still pretty new, and so it could be better, but it's definitely pretty cool. So I mentioned earlier, right? So you can do that Sysdig with that full output, and then you're filtering down. So you can also do that of like, all right, things are running slow right now. I'm doing a bunch of things to fix it, but I want to look back at it later. So you can run Sysdig, dump all that stuff to a file, and then later go through and use Sysdig to do analysis. You can load up those little captures instead of running in real time.
Can you port those captures?
Yep.
Take a capture and analyze it.
That's right. It has all the data needed for analysis in the file. And yeah. And then Sysdig also comes with this little script called Sysdig, which is less useful for like This is broken. I'm trying to see what's going on exactly on this thing I know about, but can be useful if you're doing full system debugging. So, you know, it gives you an HTOP type interface, but you can jump in and collect data on exactly what's happening inside it. And then jump in and see. I might not have picked a good process. And I don't end up using that very much. I mostly use these tools for the sort of, this thing is broken, or I'm trying to use this tool that doesn't log in a reasonable way as a replacement for that. And for that, I find they're really, really great. They offer, especially Sysdig offers a whole bunch of additional features. But I really haven't gotten to the point where I'm an expert on any of those. But I do the network listening and the file sniffing in Sysdig all the time. It's pretty much replaced my use of TCP dump or anything like that, because it's just so much easier to be able to limit down to that port really quickly, or even down to the container. So there might be tons of things talking on port 80 on your system if it's containerized, but you can just filter down to that one you care about. It's really slick. So for memory leaks, you could verify it's happening using strace or Sysdig pretty easily, but it would be very hard to know what the cause was from these tools. So I think you would need to actually have language level debugger to be able to fix those. And that is kind of the upside and the downside of these tools. They're an outside view in of what your code's doing. So when you don't know what's happening, like this is an unknown system with something wrong, it's a really easy way to figure out where to look at next. But if it's like a really well-known system with all sorts of debugging tools and things you've already built in, it may not be the most useful for you. But I find that especially when I'm dealing with some open source PHP app I've dealt with, or something that's been written by a team over 5 years, you know, it's not this really well-known thing that I understand how it works. It has a bunch of debugging flags I can turn on. It's this thing that's easiest to treat as a black box, get an idea of where to look, and then, you know, start patching in extra debugging or trying to figure out how to configure the logging better. All right. I think that is everything I wanted to cover. My slides and everything, and examples, including there's a bunch of shell scripts that just run through a series of the examples, are all in the Git repo. Yeah, just a couple wrap-ups. So, oh, great, start over. So generally, I use strace. Well, first, if you don't have root, it's great. When I know one thing is slow, but I'm trying to find what it's doing, like if you can run it from the PHP command line and then just put strace in front of it, sometimes it's just so useful. You see it, you see the system call hang, you know right where to look for next. I mean, it's hard to beat that simplicity. Like if it runs slow on the PHP command line, put strace in front of it and try that as one of the first things you do. It might not answer, but if it does, you just save yourself a ton of time. And I use it all the time in those cases where I've configured something wrong, or I've inherited something that's configured wrong, logging's broken, or logging just stopped working. Really easy to see, all right, there's that error message of the file that won't write. And, you know, logging was broken, so there's no other way to find it. Or I have this CLI script that's running. It's been running for multiple hours. Is it still doing what I expected? You can just quick attach to it and see that. And I tend to use Sysdig a lot more for looking at network level. Like it has a whole bunch of other features, but there's a bit of a learning curve to that querying language, where like if you know like 4 things, you can use strace effectively, but for like each one of those things in Sysdig, it's another set of chisels and filters you have to learn. So I think maybe like in the long runs, becoming a Sysdig expert pays off, but I really find I use it heavily for looking at what's going on with the network traffic, or especially what's going on in that container when I'm using Docker heavily. And yeah, it's for sure it's become my replacement. For every case where I go to TCP dump in the past, I don't anymore. I use Sysdig instead. All right, and then just to kind of my final wrap up is we're hiring DevOps engineers. And this is one of the tools that we use on a regular basis. If you have questions about kind of what the day-to-day is, Oscar here is on the team, and I'm sure he'd be willing to share some fun stories. So all right, thanks guys.
That ability to attach is a cool feature. That's like, I think we've done that. Right? You run some bomb, it's